बिना किसी देर के समझते हैं डी ब्रोगली कंसेप्ट ऑफ मैटर वेव्स को। और हम इसको इतनी क्लैरिटी के साथ समझने वाले हैं कि कहीं भी आपको इस टॉपिक को देखने के बाद, इस वीडियो को देखने के बाद कहीं भी आपको कोई भी कंफ्यूजन जो है वो दिमाग में नहीं रहेगी। एंड आई एम डैम श्योर अबाउट इट। सो लेट्स अंडरस्टैंड this de Broglie concept of matter waves is also known as de Broglie hypothesis of matter waves. So just keep this in mind कि इसको हम de Broglie hypothesis भी कहते हैं matter waves का। de Broglie, the full name was Louis de Broglie। तो वो एक फ्रेंच फिजिसिस्ट था जिसने एक बहुत ही बोल्ड आइडिया रखा। उसने कहा कि नेचर लव सिमेट्री। व्हेन इट कम्स टू नेचर, व्हेन इट कम्स टू सिमेट्री, नेचर लव्स इट। तो उसने कहा कि इफ द रेडिएशन बिहेव्स एज अ पार्टिकल अंडर सर्टेन सर्कमस्टेंसेस, उसने कहा कि रेडिएशन अगर पार्टिकल की तरह बिहेव कर रही है इन सम सर्कमस्टेंसेस, एंड देन इट बिहेव्स लाइक वेव इन अदर सर्कमस्टेंसेस। सिमिलरली वी कैन इवन एक्सेप्ट दिस थिंग कि कुछ एंटिटीज दे कैन हैव, if they have properties of particle, if they are particle in nature, then even they have this wave like properties also in them. So they'll exhibit those wave like attributes also. That's what de Broglie said during this proposal. So उसने यही कहा कि all matter can exhibit wave like behavior even if they are particle in nature, but it doesn't matter because they have this wave like behavior too. That's what de Broglie said. So let's just understand this, and then I'll give you an example also. So second point देखते हैं, particles like electrons or atoms were thought of as tiny solid objects. We all know these particles is a very tiny particles, electrons, atoms. So they are very tiny particles. Just keep in mind they are particles. So they are very tiny solid objects. However, de Broglie proposed that these particles also exhibit wave-like properties, and that's what de Broglie said कि भाई इन particles के अंदर भी wave-like properties आपको देखने को मिलेंगी. This means that particles such as electrons, they don't just act like particles but also like waves. एक एग्जाम्पल मैं आपको देखता हूँ इस चीज को क्लियर करने के लिए. लेट्स सपोज मान लो कि आप एक बॉल टॉस कर रहे हो, एक स्मॉल बॉल है, यू आर टॉसिंग इट. सो व्हेन यू टॉस इट स्लोली, if you know that in terms of wave like properties it has very, relatively very large wavelength, but because the ball is so large compared to its wavelength, आप उसके wave nature को नहीं देख पाओगे. But if you look at something smaller like let's say electron, you all know its wavelength becomes significant. So when that electron moves, at very high speed, the wavelength is on the scale of atoms. So this wave-like property can be observed in experiments. Like you can see it in the electron diffraction experiment where electrons, it creates an interference pattern which are quite similar to light waves. And that shows itself कि भाई electrons जो हैं, it somehow, electrons being particle, they are also exhibits wave-like nature. So that's what the concept of de Broglie was. It tells us कि ये जो tiny particles हैं, they have a wave aspect also. And this becomes really, really significant जब आप deal कर रहे हो in quantum mechanics with small objects like electrons. This becomes really very important. This study becomes really very important. सो यही डी ब्रोगली ने समझाना चाहा इस हाइपोथेसिस की मदद से. उसने कहा एवरी मूविंग पार्टिकल हैज अ वेवलेंथ एसोसिएटेड विद इट. उस वेवलेंथ को हम डी ब्रोगली वेवलेंथ कहेंगे. और इट इज सेम एज कि हम लाइट के केस में कहते हैं कि भाई लाइट हैज दैट डुअल बिहेवियर और डुअल एस्पेक्ट कि वो बिहेव्स लाइक अ पार्टिकल एज वेल एज अ वेव. सिमिलरली वी कैन से इट फॉर मैटर आल्सो, for that small particles like electrons also कि वो particle है, even then it it have those aspects of wave like nature also. So same as what we have studied in light, we have this for matter waves here. The sum up is this only कि वो same चीज हम matter waves के लिए हम पढ़ रहे हैं. all matter can exhibit wave like behavior. It doesn't matter इलेक्ट्रॉन पार्टिकल है, क्या उसमें वेव लाइक एस्पेक्ट शो नहीं होंगे? ऐसा नहीं है, उसमें वेव लाइक प्रॉपर्टीज भी हैं. इट इज प्रूव्ड. सो अब इसकी मदद से अब हम कुछ इक्वेशंस करते हैं और बेसिकली एक फॉर्मूला डराइव करने की कोशिश करते हैं. लेट्स अंडरस्टैंड दैट फॉर्मूला नाउ. Okay, so let's try to understand the expression of de Broglie wavelength. So till now we have understood this thing कि all matter can exhibit wave-like behavior. So if E is the energy of a photon of radiation, so the same energy can be written for a wave also. So E is equal to mc square. This shows the particle nature. And similarly, we have equation E is equal to h nu, where h is Planck constant and nu is frequency of light. And this shows a wave nature. Up since both of the energy are kind of same, E is the energy of a photon of radiation, and same energy you can write it as wave also. So you can compare these two equations together, and when you're going to compare it, basically mc square is going to be equal to h nu. So now instead of this frequency, this is your frequency, you can write it by opening its formula. This frequency is nothing but c upon lambda. So you'll get this formula, and from here you can easily find the value of lambda, your de Broglie wavelength, which is h upon mc. So instead of writing it as h upon mc, you can write it as momentum h upon p. So that's going to be your de Broglie wavelength. Okay. Now, next important part. Let me just rub it quickly. Now the question is, what is going to be the de Broglie wavelength of an accelerated electron? Let's suppose to a certain extent, if the particles like electrons are accelerated. Now what's going to be the wavelength now? We can produce waves of various wavelength. That is clear to us. That is, higher is going to be the electron velocity, smaller will be its de Broglie wavelength. Let's understand it using expression. So till now we got this expression h upon p, where lambda is your de Broglie wavelength. Now let's suppose v velocity is given to the electron by accelerating it, let's suppose through a potential difference, capital V. Then the work done on the electron will be EV. What I just said, I said if small v velocity, if small v velocity is given to an electron by accelerating it through a potential difference of v, then what is going to be the work done on the electron? It's going to be EV. Now this work done is then converted to kinetic energy of an electron. So we can write it as half mv square is equal to EV. EV. Now from here you can find mv square as 2m EV to the half. This is half. And here you're going to substitute the value of lambda. Lambda is equal to h upon mv. Okay, so when you're going to substitute it, you'll get lambda as h upon this mv you got 2 me, you can erase the square root here, 2 mev to the power half. So h upon 2 mev to the power half. That's what you get. Okay, this is half. This is half. Okay. So this you get the de Broglie wavelength of an accelerated electron. सो आई होप आपको ये चीजें क्लियर हैं, डी ब्रोगली हाइपोथेसिस क्लियर है तो कमेंट करके मुझे जरूर बताना कि जी हाँ सर हमें क्लियर है. So that's it about this lecture. We'll see you in the next video. Till then, keep studying. Take care.